All right, you've seen them everywhere, right? These massive, silent giants spinning on the horizon. But have you ever really stopped to think about what's going on inside one? Well, today we're going to pull back the curtain and see how a modern wind turbine really works.
First things first, let's get the scale right in our heads. This is not your classic old-timey windmill. Nope. A single one of these can be taller than the Statue of Liberty, with blades longer than the wings of a jumbo jet. We're talking about a seriously high-tech power plant, one that can light up hundreds of homes all by itself.
So that brings us to the big question, doesn't it? How on earth does this giant machine take something as simple and invisible as the wind and turn it into the electricity that runs, well, everything? Let's dive in and find out.
Okay, to really get this, we've got to look under the hood. We're going to break this thing down into its most important pieces to see exactly how that energy gets from the air to your outlet.
You know, at its heart, it's a pretty straightforward four-step process. First, the blades capture the wind's energy. Simple enough. That makes the whole front part, the rotor, rotate. But it rotates pretty slowly, so a gearbox has to step in and accelerate that spin way, way up. And finally, a generator takes that super fast spinning and generates the electricity. It's just a beautiful, logical chain of events.
So let's zoom in on that first piece of the puzzle, the whole spinning assembly. We're talking the blades and that central piece they're attached to. That's called the rotor. Its one and only job is to be the first point of contact, to reach out and grab the energy right out of the wind.
Now think about this for a second. Those gigantic blades, they spin with incredible force, but they do it slowly, maybe only 15 or 20 times a minute. A generator, on the other hand, needs to be spinning thousands of times a minute to work properly. So how do you bridge that gap? That's where the gearbox comes in. It's like the transmission in your car, taking that slow, heavy-duty power and turning it into the insane speed the generator needs.
And this is the final stop on our tour, the generator. This is the powerhouse. It uses the exact same principles, magnets and copper coils, that you'll find in pretty much any power plant on the planet. It takes that crazy fast spinning motion from the gearbox and, like magic, turns it into usable electricity.
So, okay, we know the parts. But that leaves a deeper question, doesn't it? I mean, it seems obvious. The wind just pushes the blades around, right? Well, what if I told you that's not really what's happening at all? The real secret to why these blades spin so darn well is actually kind of surprising.
And that's because the secret isn't about brute force. It's all about physics. And it's super elegant. The science that makes a turbine blade spin has a whole lot more in common with an airplane wing than it does with a little kid's pinwheel.
Okay, if you remember one thing from all of this, let it be this. The wind doesn't actually push the blades. Instead, a force called lift literally pulls them around. Now, I know that sounds backward, but this idea is the key to understanding everything.
Just look at the shape of a turbine blade. See how it's curved? That's an airfoil, just like on an airplane. As wind flows over that curve, it has to travel faster than the air on the flat side, and that difference in speed creates a difference in pressure. And that pressure difference creates a force we call lift. For an airplane, that lift pushes the wing up, making it fly. For a turbine, that very same lift force pulls the blade forward, making it rotate. It's the same exact principle.
Yeah, it's the same fundamental science, just pointed in a different direction. One is designed to go up and achieve flight, the other is designed to go round and round to generate power. It is just a brilliant, brilliant piece of applied physics.
So, understanding the physics is one thing, but actually building a machine that can do this day in and day out in all kinds of weather without falling apart, well, that's a whole other story. This is where we get into the world of engineering, which is all about making tough choices and balancing trade-offs.
So let's play engineer for a minute. What do you think is better? A turbine with a ton of blades, kind of like an old farm windmill, to catch as much wind as possible, or one with just a few? What's the magic number here?
Well, here's the deal. A turbine with lots of blades is great at getting started in a light breeze, sure, but it's also really heavy, and it creates a ton of air resistance, or drag, which makes it super inefficient when the wind really gets going. A design with just 2 or 3 blades is way lighter, it can spin much faster, and it's way more efficient overall. And that's why today's 3-blade design is the perfect compromise between stability, efficiency, and cost.
Okay, so we're sticking with 3 blades, but how long should they be? Should they be skinny, wide? Should they be perfectly straight or have a twist to them? Believe it or not, every single one of these details has to be calculated down to the millimeter.
And the choices here are absolutely critical. Longer blades catch way more wind. In fact, if you double the length of the blades, you can get 4 times the power. It's wild. But
Longer blades are also heavier, way more expensive to build, and a nightmare to transport. And on top of all that, computers are constantly adjusting the pitch, which is the angle of the blade, to make sure it's catching the wind just right, no matter how fast it's blowing.
So, what's the big takeaway here? It's that there is no single perfect wind turbine design. Every single one you see out there is this incredible, finely tuned balance of physics, material science, and pure economics. It's truly a masterclass in engineering compromise, all to squeeze every last possible watt of power out of the wind.
All of which leads to one last really fascinating question. We've come from simple little windmills to these incredible aerodynamic giants. But as we invent stronger, lighter materials and our computer models get even smarter, where do we go from here? Are they going to get even bigger? Will they have 2 blades instead of 3? Or maybe no blades at all? The evolution of the wind turbine is far from over, and what it looks like in the future might be completely different from anything we see today.